All right, eyes up here. What we have is it's asking us to graph each set of data and figure out which kind of model best describes the data. Remember, that's, again, what I've got written right over there. That's what I'm trying to make sure you know is that there's three sets of data that we need to be able to identify. One is a set of data that has a common difference. And again, guys, how do you figure out the common difference? That's right. You subtract the y value. You know, y sub n minus y sub n minus 1. You start with the one furthest over to the right, the highest y value you got over there, and you start subtracting them coming over. And if you get a common difference, if you get the same number, guys, same number over and over and over again, you say that system is or that situation is a linear set. Or if you have a common ratio, again, guys, if it's a common ratio, you do y sub n over y sub n minus 1, and you get the same factor, the same number over and over and over again. That is an exponential situation. And then finally, if it has a second difference, that's quadratic. Again, guys, this question is going to show up. It showed up for the first time last semester when they asked us to find the slope of a line. Guys, now, how many ever weeks later, we're still finding slope. Remember, the definition of slope was rise over run. But this time, instead of asking you to find the slope, they're going to say find the average rate of change. Don't let that intimidate you. Guys, the average rate of change is the same thing as the slope. So when it asks for the average rate of change, you just find the slope between those 2 points. Or it may say over an interval or something like that. You just find the slope. Everybody good? So let's look at this. Hold on a second. -2, 5. So I want to graph -2, 5. So -2, 1, 2, 3, 4, 5 is there. So 3, 10. So I graph 1, 2, 3. I go up 10 right there. So 0, 1. So it looks like this thing's going to be up and over 1, up 2. So it looks like the best that this is going to be is a quadratic in here. So if you subtract, I'd have to get these things in order. Guys, look, they're not in order. I need to get them in order, and you should be able to see, and they would have what would be close to a common difference. Okay, here, 0, 3, 2, 12, -1, 1.5, -1, 1.5, -3, 4, 48 up there. Okay, this is somewhat of an exponential growth problem. So the model that best describes this would be an exponential growth. So that's when that number right there is greater than 1. This right here is pretty much a quadratic situation. They're just wanting you to get the general idea of what these things are. Now, what you can then do is once you decide what they are, just like we did with that one problem, guys, you can plug them in. Look, you can plug them in here, and you can come up with what some possible values are. And that's all they're wanting you to do. Somebody said, Coach Hill, and I said, hold on a second. Yeah. Anybody get one? Anybody find a pattern here? Linear.
What page you at?
It's that next page. Should be on the back.
That's two.
Anybody? So what is that one? Exponential. Really and truly, if you look at these numbers, both of these are negative. It's really negative 3 over negative 6. It's really negative 6 over negative 12. It's really negative 12 over negative. Why didn't I put the negatives in there? They're both negative. So since they were both negative, I knew it was 2 negatives is going to make a positive. So if I actually drew out what this was, I know that I have a negative in there. This is 12, that's 1/2. So I know I'm getting, I know I'm getting this from having a negative right there, so I just put a negative out in front of all this stuff, and it should be able to give me, that should be able to the equation that gives me that numbers. Plug in a 0, that's 1 times negative 6 is Guys, I'll put the rest of this in my other classes.